Hey everybody, so here is tutorial 3 part 2 where we're going to continue where we left off from tutorial 3 part 1. The first thing I want to mention something within tutorial 3 part 1 before we move on is if you take a look at these spheres, you'll see they have a very coarse edge to them. They're not very smooth spheres. And that can be good if you're rendering a huge number of objects, because the higher the dimensionality of an object, the harder it's going to be for the computer to render it. But in this case, we only have 20 objects, so we might as well make smooth-edged spheres. So we can target 0, target all the spheres, and set their dim to a nice high dim value, like 50 by 50. And that's going to give us smoother edged spheres. So if we zoom in now, we see that we're getting a much nicer, smoother edge. But if we're going to be going in really close, we can still see that this is not entirely round. Then we can go up to a very high dimensionality, like 100 by 100, to give us a very, very smooth edge on the sphere. But again, this high dimensionality is going to be harder for the computer to render, so we don't necessarily want to go there. And we only need high dimensionality if we're dealing with curved shapes. If we're dealing with things like cubes, we can work with very low dimensionality. I can take this down to dim 10 by 10, which looks terrible on spheres, but looks fine on cubes. Something we can do with the tools that we have right now is we can make a little city. We can take the rectangles that we're working with right now and render them as suggestions of buildings. How would we go about doing that? Well, firstly, our color palette is not right for an urban setting. So why don't we just make a simple change here and make these, instead of being all different colors, we'll make them all shades of gray. That's a very straightforward thing to do, because right now we're generating 3 random values here representing red, green, and blue, and we are sending the color message. And here it's a little bit clearer if we use the $1, $2, $3. We're sending these 3 random values to all 20 of our shapes, where the first value represents red, the second value represents green, the third value represents blue. Well, shades of gray are simply colors where the red value, the green value, and the blue value are the same. So in order to make this gray, all we need to do is say, take the first value of the 3 and send it to red, green, and blue, and we're going to get all shades of gray. And if you forget that that's how shades of gray are made, that's an easy concept to get back to. If you think about the fact that black is 0, 0, 0, white is 1, 1, 1, halfway between black and white is gray, 0.5, 0.5, 0.5. If you make that darker, you move towards 0, 0.2, 0.2, 0.2, that's going to be a dark gray. If you move towards white, that's going to be higher values, 0.9, 0.9, 0.9 is going to be a bright gray. So whenever it's a gray, your red, green, and blue values are identical. And what we can do here, since we're only using $1, we actually don't need a jit.noise 3. We now only need a jit.noise 1. So there we've just simplified this to give us arrangements of shades of gray for our building colors. That's fun. I'm going to just take this whole structure and encapsulate it so it gets out of our way, and I'll call it building color. The only trouble you can get yourself into with encapsulation right now is if you encapsulate a jit.gl.grid shape and separate it from its jit.gl.material. These two need to be in the encapsulation together. Okay, so how can we make these all stand up vertically like buildings? Well, first of all, let's take a look at how we're scaling them at the moment. We're scaling them randomly, but notice they're long rectangles, which means we must be doing some kind of math on the random numbers, because the random numbers are going to be proportional, so they should give us squat rectangles closer to cubes. These long rectangles mean we're doing something in the jit.gen here. So let's open up the jit.gen and see what it is. And here we can see, aha, we're stretching them out 3 times on the x dimension, 0.3 on the y, and 0.3 on the z. And that's a scale. So we're taking the random values coming in, stretching them on the x, and squashing them on the y and z. And then we're biasing them, meaning we're creating a minimum size. We're adding some some base amount to all of them. We can hold on to that bias. That's not a bad thing. But for the scaling, we want our buildings to be tall. So why don't we do something like 1, 5, 1, meaning we're going to accept the random value that's coming in on the x-axis, the width of the building, and multiply it by 1, meaning keep it the same. But we're going to make our buildings tall. We'll multiply them by 5, or heck, why don't we even try 10 on the y dimension, and then 1 on the z dimension. So we'll accept the values coming in, and then we're going to add, let's bias them by 0.5. And these are just, values to try, values to play with. If they don't work out, we just try different values. So let's close our jit.gen. These are much more building-like buildings. Maybe 10 was too much. We'll go back into this jit.gen and just say 5. Let's see what we get here. These look considerably more building-like. Now there's still a couple of things. One, their position is not right, and their rotation is not right. So since they're buildings, they don't actually need to be acted on by forces, so we can make them kinematic. We want to rotate them so that they're all standing upright. So rotate x, y, z, 0, 0, 0. There. So physics instructions sent to the physics input, and dimensionality and shape instructions sent to the grid shape input. Now we're looking at something that's more like a city. And if I reset my handle and zoom out a bit, I can see, okay, I'm getting something somewhat building-like there. And in terms of the random positioning, we can see that things are too close together. So we'll go back into our jit.gen and we'll scale them differently on different axes. We can spread them out quite widely on the x dimension. We want them all to sit at 0 on the y dimension because they're buildings, so none of them should be floating above the ground. None of them should be totally underground. So we're spreading them out on the x. We're not spreading them out on the y. In fact, we're zeroing the y. And we're spreading them out on the z to make a sort of a city block. And we're starting with our bias of 0.05 so that our random values coming in are between 0 and 1. We're biasing them by 0.5 so that they're in a range from minus 0.5 to 0.5, so that when we scale them, we're getting negative values and positive values. Still too crunched. Let's go in there and try doubling that. That's better. Let's make it even a little bit bigger. Yes, now we're getting something that looks much more like a city block. Yeah, great. Now, we see that there's one obvious problem with our city block here, which is the buildings look good on the top, but then they're kind of mirrored on the bottom because they're being scaled from the center. And there's a number of ways to solve that. Some are more complicated than others. I'll show you the simple way to solve that, which is just to make some ground, some street level. And that solves our problem immediately. Now our city is nicely sitting on the ground. And if we look underneath, we'll see there's sort of a mirror city underneath the ground. That doesn't matter. As long as we're only seeing it from the top, it looks like these are all buildings that are sitting on the ground. We can put a jit.material here so the ground has some reflectivity to it, and reset. And oh, what happened to it? Well, our camera is at position Y0. So when we reset our handle, we're actually inside this cube that we just made. That's the floor, so we can't see anything. And here I'll show you, if I just delete that, we're looking at our buildings. But if I put it back, we're actually inside this floor we just made. Not a great place to be. So let's just move our camera position up to, say, like 10 meters above ground level. Yeah, and now, we've got a vantage point on our new city, and every time we can randomize the colors of our buildings, we can randomize the positions of our buildings, and we can randomize the scale of our buildings. Cool. And We can also make a lot more buildings. This is one of the nice things about, once you've created a structure like this, you're like, this is great, I love it, but I wish I had 50 buildings. Well, boom. Now, we're only seeing 20 buildings here because our 50 buildings are only being moved into 20 positions and 20 scales. So we can move them into 50 different positions. And you can see the ones that haven't been scaled yet. So we need to move them into 50 different scales, and a bunch of them are red, but assuming we want them all to fit in with this scheme, we'll want 50 different shades of gray as well. We could write a book about that. If we save this and close it and reopen it, turn the world back on, we can generate our city very easily. And then anything that we, any multiple clicks we have to do, just stick the button on those so we don't have to do the multiple clicks. And you can always test this out. Save, close, reopen, and there's our city, and every time we click, our city's going to re-randomize. Now, you don't have to make a city. You can make mountains, you can make planets, you can make stars, you can make mad scientist laboratories, you can make what interests you. A city is an easy way to demonstrate to you that these tools are flexible for creating a bunch of different stuff. So what I'd like to do now is take our cube, which is still here, kind of buried in the middle of the city, and look at changing and manipulating that a bit. Before I do that, I'm just going to skip back and do a little encapsulation here. And make sure that these all still work. I can scale my buildings, I can position my buildings, and I can change the color of my buildings. That's great. What can we do with our cube that is actually now hidden by our city in the center there? Well, we can change its position. We can give it a position message. Let's just move it where we can see it. 5 meters above the ground, and now we can see our cube. And that's cool. And we should, even if it's going to be a kinematic object, we should make this a physics object. So we'll do a jit.phys.body at kinematic 1, and we'll actually position that. And this is also at scale 2 because this scale gets overridden. And it's also at shape cube because the shape needs to be in both the phys body and the grid shape. Connect that up, position it, and now we have a kinematic version of our cube. So let's look at how we would position that in real time. Well, we have a position message here. We can make that position message changeable by using the changeable arguments, $1, $2, $3. And we have a new user interface object that will allow us to change all three of those changeable objects. It is called the multi-slider. So you type multislider, and if you just start typing, it'll fill it in for you, multi-slider. Stretch this out so it's wide, and we have to set some parameters of this multi-slider so that it can be used the way we want it to. So I'm going to introduce a new part of the Max interface, which is this letter I right here, the inspector, which is going to let us change things about the multi-slider. So with only the multi-slider selected, click the I, and here's a bunch of attributes of this multi-slider. So going down, we'll start at the bottom. We want 3 sliders because we're going to be changing the position of the cube. And we want to range from, let's say, -5 to 5. 5 meters to the left all the way to 5 meters to the right. So 3 sliders from -5 to 5. we want continuous data output. So we want to check that box for continuous data output. And as a slider style, we want bar sliders. And then up top, we want alternating candy cane, 3 colors, and also orientation horizontal. And then we can choose the 3 colors here. They're set by default as this. I like to set them to red, green, and blue so that you can use this same slider for a color slider later. Just to review one more time, alternating candy cane, 3, orientation horizontal, set your 3 candy cane colors to whatever you want. Number of sliders, 3, range -5 to 5, continuous data output is checked, and slider style is bar. And the rest of the values will be set correctly by default. And this gives us a multi-slider, and we can just hook this up to our position 1, 2, 3 message, and we are now moving our cube from -5 to 5, from -5 to 5 on the y-axis, and from -5 to 5 on the z-axis. And if that's not enough for us, we can go back in here to our inspector and change this range, or there's a nice message that does this for it. It's set min max, and we can say -10 to 10, and send that message to the multi-slider, and now it gives us a 10-meter range, which is nice. And with the set min max message, after you've sent it, you can actually delete the message. It will, the multi-slider will retain those values. Another useful message to have is a 000 message, which just allows you to reset your slider to 0. I'll show you one other thing, which is kind of a power user trick, but might be handy with something like this that has so many settings that you need to set. Click on the object and go down here to, there's a paperclip with a plus that says Save Snippet. Click on that, and you can give this a name, multi-slider, 3 sliders, whatever you want to call it is fine. It says Snippet Saved. Now, anytime you need one of these with those exact settings in place, you can go over here to this paperclip and start to type and see it says multi-slider 3 sliders. Double click it, and it makes one for you with exactly those settings. And you can use this for anything. Anything you want to reuse, you can highlight it, save the snippet, and then whenever you want to, go back and recall the snippet. And as you can see, I have tons and tons of snippets saved so that all the stuff I use on a regular basis is there for me. And there's also tons of built-in snippets too. And of course, the other way, if you just need to make another one of these, is to Command-C copy, Command-V paste, and that'll duplicate it as well. But the snippet is handy if you're working in a blank patch. So this is really great. I can now move my shape around interactively, which is something we haven't been able to do before. If you want to save a value, find a position that you like there, I want to be able to get back to that position. You can use the right inlet of a message box to create a button that has these values in it. So now when I adjust this, see the values are saved in there. If I disconnect this message box, I can use this message box as a button going into the multi-slider to get me back to those values that I want. And we can do it again. We can take another message box, use the right inlet of the message box, find another location that we like, and disconnect it, put it over here, and now that becomes a button to take us to another position. So we have this position that we like and that position that we like in 0. Let's look for a moment at transforming this cube into a sphere, which we also need to change in its fizz body. And notice that when I change what's inside this fizz body, my sphere disappears. That's because it went back to position 0, 0, 0. So now I can use one of these buttons to put it back in the position that I want it to. Why did it go back to 0, 0, 0? Because when you change the typed in arguments of an object, the object will reset itself. So let's make this a planet. Make it a striped planet like Jupiter. So instead of making 3 by 3, I'm going to make 1 by 12, and that's going to give me stripes. My stripes are going the wrong way, so I'll try and switch it around. 12 by 1. That's not going to work. That's going to give me a beach ball. All right, so I had the stripes right the first time. Why don't I just rotate X, Y, Z. Rotate this on its x-axis by 90 degrees. It disappeared again. I need to reset the position, and now I have a stripy planet. Wonderful. Nice stripy planet. My stripes are hard-edged because of this. This matrix is scaling up the resolution. If I take this out, I'll get smoothed edge stripes. And if I want to sort of split the difference and not have them be that smooth, I could, for instance, knock this resolution down, maybe 10 by 30. Let's see what that looks like. Okay, so those are nice softer edge stripes. So I'm generating a 1 by 12 matrix of colors, but then I'm stretching it over a larger matrix to get smooth gradient transitions of color. I'm not liking any of these color combinations. So I'm going to do a little bit of additional work here to get some nicer looking colors. I am going to add a jit.gen and do a little bit of processing on this color matrix in the jit.gen. I could say multiply and take out all the reds. Maybe this is a blue-green planet. So I'll say vec 0, 1, 1, meaning multiply red by 0, which will give me all zeros, multiply green by 1, and multiply blue by 1. And this is our blue-green planet. That's okay. I'm still not excited by it. I'll go into the jit.gen and say, all right, what if I wanted to make it like a pink and orange and yellow planet? Well, then I could add red to this. So here I'm stripping out the red, so the red is always 0, and then adding a fixed value of 1 for the red, so the red is always maximum. And the reason why I'm doing it in 2 steps like this is so that I don't get values over 1 for the red. That's nice. Pinks and whites and yellows. That's a great looking planet. The other way to handle this same thing, if this is a little bit confusing to you, would be to introduce a new object and say, I want to add 1 to my red, so my red is always at least 1, and add nothing to my green and nothing to my blue. But in that case, I'm going to get values for red that are greater than 1, which are not technically legal. So I can use clip, let's say clip 0, 1. It'll just clip all my values between 0 and 1. So any red values that this takes over 1 will be clipped to 1. And I'll get exactly the same result. The only object that accepts color values greater than 1 is jit.gl.light, where you can send color values greater than 1. That will just make the light brighter and brighter. But objects should not be colored outside the 0 to 1 range, so just use clip 0, 1 if you want to keep everything within the range.